Hey everybody, this is Mr. Storm. Today we are going to get into our next project, which is this dark 2D platformer. I didn't know really what else to call it. This is just going to be kind of a prototype of how 2D platforming games work. This isn't a full game. There's going to be no win condition for this game. It's just going to be movement. But we're going to play around with some new things in Unity and in scripting in general that are going to help us get some cool effects that we can use in a bigger and better project later on. So really quickly, I just want to show you what this game looks like when I hit play. I have my camera there and I can't move my character. My character is this red ball here. I can't move him, but I want him to be able to jump around the level and do cool stuff. And also this background here, this is just some texture I found online that looked pretty cool. We actually want this to move around with our character. We're going to do that in the second part of the project. This first part of the project, however, is just going to be us, sorry, it's just going to be us creating a movement script for our character. So let's go ahead and open up our scripts folder, which it is empty. And I'm going to create a new C# script, and I'm going to call this player. This is going to handle all of our players' interactions in the game. And we'll let it build itself here. Okay, and then I want to attach this to my player object right away, just so I don't forget to do that later. So I'm going to just drag this over. So we can do it that way, or we can go add component, go down to scripts, and find it in there if we want to do it that way. All right, so now my player component, or my player object, has a player script attached to it. And let's go ahead and open up that script in VS Code. Now, if you're using your home computer and you have Visual Studio installed, or if you're using MonoDevelop, this will all be essentially the same. I'm just using VS Code because it's a lot snappier. It's a lot quicker. The debug tools aren't as good as Visual Studio, but it's a lot quicker to save files and port them to Unity and things like that. Plus, this is the IDE that you'll be using in the computer lab. So hopefully this will be familiar to you. Okay. So if you remember back to the last project, we had a movement script, but that movement script moved us in the X, meaning horizontal, and the Y, which is vertical. We don't want that for this because we want it to just move in the X, and then for the Y movement, we want it to actually jump. And so there's some different things we're going to have to do here. First of all, we need to start out with a public float. We're going to call this move speed, which is going to handle how fast we're moving. And I'm going to set it to 15 right off the bat. And then, let's see. Okay. Now, before we get too far, we have to talk about the concept of what we're doing. Let's go back over to Unity so we can pay attention. We can think about this. So with a 2D game, with a 2D side-scrolling game, if I just do my movement the way we did with the last game, then when I let go of the, let's say, the right arrow, then the character stops immediately. And that doesn't really feel natural for a 2D side-scrolling game. We're all used to Mario movement because Mario was, the first 2D side-scroller. And when you stopped moving in Mario, there was a little bit of a slide. He slid just a little bit before he stopped, and it felt more natural. It felt like he's running, and then he stops running and he slides. So we want that kind of feel for any 2D side-scrolling platformer game so that it doesn't feel unnatural to the player. All right, so in order to do that, we're going to create this new thing called a range. So I'm putting it, range. I'm putting it in those brackets so that we can essentially serialize it. We can put it on our, it's kind of like making it public, but I'm setting the range here to 0, 1, because we want it to be a range between 0 and 1. And I want to make it a public float called sliding. All right. I'm going to set it to 0.9 just to start us off. And I need to put F behind there because it's a float. So now that what this range does, let me show you. I'm going to go ahead and save my script. So File, Save, and go back over to Unity. Let it compile. Okay. Now when I select my player object, you'll notice now not only do I have my move speed here that I can change, but I have this cool slider. And this is a range from 0 all the way up to 1. And so that's one of the cool things we can do with scripting and the Unity editor. We can create a slider that allows us to change a value pretty easily. Okay, cool. I just wanted to show you guys that. Next thing I need is public float, and I'm going to call this jump force. We're going to use a new method called add force to create our jump force. And I'm going to set it to 1200 to begin with because that's a pretty good jump force. Okay. Let's see, what else do I need to do? I think those are all the variables I need to create for right now. Now let's start actually moving this guy around. Okay, so in the last project, what we did was we created an rigid body 2D and we set a reference to that and start and all of that stuff. We're not going to do that with this project. I just want to show you there's different ways to do everything. The way I did it last time is my preferred way, but some people were asking about condensing lines of code so that we didn't have so many lines. So I'm going to do this one as efficiently as possible without too many lines on the screen. Okay, so we have void update. Now update's a good method for checking every frame, right? Update is called once per frame. Now with movement in this fashion, where it's physics-based movement, you rarely want it to check every frame. What you want to do is you want to set it to fixed update so that it will check it at a fixed interval instead of checking every single frame. So we're going to change update to fixed update. And then we're going to start bringing in our input values. So the first thing we want is a float called h, and it's going to be input.get axis raw. We did this last time. We're basically bringing in our input, and hopefully you're ahead of me already, and you know it's supposed to be horizontal. Okay, so we're bringing in a horizontal input. Now, the next thing we're going to do is we're going to create a new vector 2, and we're going to set the rigid body dot velocity to this vector 2. It'll help us later on. So vector 2, and we're going to call this v. This is going to be our vertical. Instead of bringing in input, we're going to just take the velocity of our vector 2 and keep that as our vertical. So get component, and it's going to be rigid body 2D, 2D, and put those there, and then dot velocity. Okay. So there we go. So now we have an H for horizontal, a V for vertical, and the V for vertical is actually storing the velocity, the current velocity of the object at any given time. Okay, so now what we need to do is we need to check to see if we're already moving. All right, now the reason for this is because we're going to make that slide happen. So if H, I'm sorry, not check to see if we're already moving, check to see if we're hitting the left or right keys. So all we need to do for that is if H does not equal 0, meaning if this input value is anything other than 0, if it's -1 or +1, then it's going to run this if statement. And this if statement is going to be get component rigid body 2D and dot velocity is going to be set equal to a new vector 2, and that vector 2 is going to be h, so whatever we have on the h, times our move speed. This should be pretty familiar to you so far. And then the next thing we're going to do is we need to set the v.y. So basically all we're doing there is we're setting this velocity, and we're going to keep its y value as whatever it already is. So we're just going to go v.y. Pretty easy stuff. Because again, we're not changing the vertical, right? We're just moving back and forth. Okay. Now, if we're pushing the button, then we want that to happen. But if we let go of the button, if the button's not being pressed, then we want to do this thing. This thing's pretty cool. So what we want to do is get component rigid body 2D. So do you see why I created a reference for my rigid body 2D? Because if we're going to use it multiple times in the script, it just makes sense instead of typing this whole thing out every single time. But like I said, some people wanted to see it differently, so I decided to do it differently for this velocity equals new vector 2, and this is going to be v dot x times sliding, and then v dot y. Now, let's explain what that means. So what this is saying is we're going to take our velocity as it stands right now, and then if we're not pushing the button, then what we're going to do is we are going to multiply our v dot x times sliding, okay? So we're going to multiply the x by sliding. Now, if you think about it, we set our range so that it can never be above 1, okay? So it can never be above 1, which means we're going to have a decimal value in here somewhere. So if you times, positive x by a decimal value, then that's a percentage of it. So every frame, it's going to slow down, right? Because we're giving it a smaller and smaller percentage every frame. This is actually kind of a cool trick, a cool math trick that we can use in order to make this slow down naturally. Alrighty, let's see. Is there anything else I need to do before we move on and test it? I think that's it for this portion, just for moving back and forth. Let's go ahead and save this. And I'm going to head back over to Unity and make sure it's compiling. Okay, did it save? Felt like that was faster than it should have been. All right, well, let's try it out. There's no way to know except for trying it. So nice. So I get this nice, cool, smooth movement. And when I let go, he actually slides a little bit and it feels a lot more natural. I still can't jump, but I at least have my movement here and it's working really well. Now, very quickly, let's go ahead and grab that main camera and make it a child of the player. It's not going to be like that forever. Oh, actually, you know what? We're not going to do that right now because let's change our projective back to perspective. No, let's go back to orthographic. We'd have to change the parallax camera, and I don't really want to do that. Yeah, I don't really want to do that right now. We'll leave that alone. This isn't going to look very good. It's going to be... Oh, actually, you know what? It still works. So now I can see my cameras following me around. Okay, good. The reason I didn't want to play around with these two cameras is because these cameras are set up perfectly in the project for the next video when we're going to set up parallax scrolling of that background, and I didn't want to mess with it too much because I don't want to throw off some of the values and have some issues later. Okay, anyway, so now I can move. Let's go ahead and do our jumping. Okay, so jumping is actually probably easier than you might be thinking. All we need to do is we need to check to see if we have something below us. So we need to check to make sure that this object has something directly below it. If it does, then we're going to add some vertical force to our object, and then we can move it around with the arrow keys while it's in the air. Now, the adding vertical force is super, super easy. Let's go ahead and do that. Okay, so I'm going to, underneath my if-else statements here, I'm going to add get component rigid body 2D, and I'm going to set its, actually I'm going to do add force, and that's going to be vector 2.up times my jump force. Okay, jump force. There we go. And that's it. That's how we make jumping. But here's the thing. That only should fire when we're pushing a specific key on the keyboard, right? So I'm going to actually wrap this in an if statement. If input dot get key, I'm going to make it set to key code dot up arrow. Now, we can set this to whatever key we want. We can set it to an axis if we want, which is probably best. That way you can use a controller with it. But for now, I'm just going to set it to the up arrow because it makes sense. I'm going to take this line of code that we wrote. I'm going to cut it out, and I will paste it in here. Let me get my tab straight here. Okay, so now if I push that up arrow, then I should jump. So let's go ahead and save my game, or save my script. rather, and then let it buffer here. Okay. And let's test it out. Okay, so I can run back and forth, and oh, I can jump, and that's a lot of jump force. Oh gosh. Now, what's happening? Okay, and I'm flying off the screen. What's happening there is either, there's a couple things that could be happening. Let's talk about what all they could be, just so we can pay attention, so we can understand what we're doing. Either my gravity scale is too low, which it's set to 10, which is pretty good, or my jump force is too high, which it's 1200, which is pretty good. Or the third thing, which I suspect, is that I'm jumping and it's basically jumping me forever, right? Because I push the key and I might be holding the key for half a second before I let it go. And there are a lot of frames that fire off in half a second, 30 to be exact. And every time that frame fires, it's adding more and more jump force to my character, meaning I'm basically just, he's a rocket ship, right? So we want to fix that. We want to set it so that if input.getKey keycode.up arrow and he's grounded, there's something below him. So in order to do that, we need to create a new method, and we're going to call this this is going to be a bool, by the way, a bool method, and we're going to call it isGrounded. Okay. Now, this is going to be slightly complicated. The thing about this method is that it uses some this concept called raycasting, and raycasting is essentially just a code-based representation of some pretty high level, well, not really high level, but some trigonometry stuff, some high level geography, or not geography, geometry and trigonometry, and a little bit of vector calculus thrown in, right? So I'm not going to be teaching you all that stuff, but what I will do is try to walk you through this method as I write it so that we're not too lost. Now, it's not super important that you remember how to write this method or exactly what everything does. I just want you to know that this method exists and have an example of it so that you can use it later on whenever you need to do some kind of jumping. Component. And it's going to be collider 2D. And it's going to be dot bounds. Oh, bounds. There we go. Okay, so what this statement does is it creates a new object of bounds type, of the type bounds, meaning the bounds around a something, bounding box. And I'm going to name it bounds. And then it's going to be equal to getComponent dot collider 2D, and then the bounds. So I'm basically saying, all right, this object that I have this script attached to, I want to get the boundary of this collider 2D. I want to find the edges of this collider 2D. Okay, and then float range equals bounds.size.y. So I want to figure out how tall it is, times 0.1f. Okay, so I want 1% of its height. I want 1% of it. So bound, so type, yeah, okay, 10%. I want 10% of its height. So I'm going to check 10% of its height below itself here in a second. So I want to make sure I know what 10% of its height is. That's what that statement is doing. Okay, and then vector2 v equals new vector2, and it's going to be bounds dot center dot x bounds dot min dot y minus range. Okay, this is a long statement. So I'm creating a new vector2. I'm calling it v. Now, here's the thing. We've already used v up here as a vector2, but because these are two separate methods, it doesn't really matter. We can use the same variable name, but they're not the same. So just, don't get confused. All right, so I'm just creating a new vector2 called v, and it's going to be set to a new vector2, and the x is going to be bounds.center.x, so the center on the horizontal axis, the center of my object, and the bounds.min.y is the lowest part of the bounds minus range, which is our 10%. So we're grabbing that 10%. We're setting a new vector2 for the bottom 10% of my object. Now we're going to raycast hit 2D. I'm going to call this hit. So that's a data type of raycast hit 2D. We're going to call it hit. And then we're going to physics 2D dot line cast. And the line that we're going to cast is going to go v bounds dot center. Okay. So what this is doing is it's creating a new, basically a line. We're drawing a line from V, this range here, this 10% below the object, all the way up to the center of my object. We're just drawing a line between the two. And then all we have to do is return, and it's going to be hit dot collider dot game object does not equal game object. Okay, so this is where we figure out true or false. So this is going to return true if hit.collider.gameObject does not equal gameObject, meaning it hits something, but it's not hitting itself, right? If it hits something and it's not hitting itself, right, then it has to be hitting something else, meaning it's standing on a solid object. Okay, again, like I said, these 5 lines of code right here are really complicated and probably really difficult to understand. So again, I don't expect you to understand how all of this is technically working. Just know that you have this bool is grounded method that you can use whenever you want. Okay, now we just need to add is grounded up here in our fixed update. So let's set a value, bool, we'll call this grounded, and set it equal to is grounded. So we can call that method. So we're going to check here before we start taking in input and moving our character. We're going to check to see if we're grounded first. And then here in input.getKey keycode up arrow, we're going to say and grounded, meaning we're only going to do this if we are grounded. If we're not, we're going to ignore this statement and we're not going to jump. Okay, that I believe is it. That is it for our movement. Let's go ahead and save this file. Save. Go back over to Unity and check to see if this works. Okay. Buffering, buffering, buffering. There we go. And hit play. Okay. So I'm moving, 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 and I jump. Okay, now notice I'm not getting those crazy weird swings like I was before. I'm not rocket launching up into the sky. I'm jumping at a reasonable height. Ooh, and you know what? There's a little bit of a glitch here. If I hit just the very edge of that box, I kind of launch into space. That we would probably need to fix later, but for now I'm going to leave it alone. But my jump is super small, or it's not as tall as I want it to be. So I'm going to set my jump force to 1500 and see how that affects everything. All right. And that's much better. I can actually get up there. I can get over there. Okay. Okay. That's good. And that's really all we need for now. I just want you to be able to move your character around and jump around and stuff like that. In the next project, we're going to get into environmental controls, meaning if we run into these spikes, then it resets the game, which you already know how to do. And we're going to do some other stuff. We're going to make that background scroll. We're going to create a better camera follow script that feels more natural, because this one's kind of janky. But we'll do all that in the next project. So for now, thank you for paying attention, and I will see you next time.